As part of the present administration's efforts to curtail the spread of coronavirus COVID-19 ravaging the country and the world at large, Edo State Ministry of Education, in collaboration with Edo Broadcasting Service (EBS) and Academic Staff Union of Secondary Schools (ASUSS, is organizing a television program for students in senior secondary schools, particularly those writing the West African Senior School Certificate Examination (WASE), the National Examination Council (NECO), and National Business and Technical Examination Board (NAPTEB) for the year 2020 in the months of May, June, and July. The program will be held on EBS television channel every day from 12 noon to 1 p.m. beginning from Monday, April 6, 2020. The subjects selected for these programs are Mondays Mathematics, Tuesdays English Language, Wednesdays Physics, Thursdays Biology, Fridays Geography, Saturdays Civic Education and Economics, and Sunday Chemistry. Parents and guardians are therefore advised to draw the attention of their children or wards to this opportunity during the stay-at-home period.
Good evening, viewers. I am Aghagbora Osaro by name. And today in our television series, we are going to be having our subject chemistry. We are going to be continuing from where we stopped in the last chemistry class, which is hydrocarbons. And in the first class, we looked at the hydrocarbons, the different class of hydrocarbons, the saturated hydrocarbons, the unsaturated. We looked at the source of hydrocarbons. But today we are going to look at an example of the unsaturated hydrocarbon. In the last class, we looked at saturated hydrocarbon, which is alkanes. But today we are looking at unsaturated hydrocarbon. Under the unsaturated hydrocarbon, we have alkene and we have alkynes. But today our class is going to focus on the alkenes. Now the alkenes are the first example of unsaturated hydrocarbon. They have a general molecular formula. The general molecular formula is CnH2n. That is their general molecular formula. Now from this formula we can bring out the molecular formula of the alkene and the structural formula of the alkenes. Now if you remember, the general molecular formula for the alkanes is CnH2n plus 2. But if you look at our formula for the alkenes, is different with just these two being removed. And so for the alkenes, they are always short of 2 hydrogen atoms. Now let's quickly look at the molecular and structural formula of the alkenes. N is greater than or equal to 2. N has a value that is greater than or equal to 2. And so therefore, if you have when N is equal to 2, when your N is equal to 2, the formula of the first member of the alkene is going to be C2H2 times what? N, which is what? 2. And that gives you C2H4. This is the formula for the first member of the alkene. And so you have C2H4. If you want to bring out the structural formula is CH2. Now what really makes a hydrocarbon unsaturated is the presence of double bond in between the carbon atoms. In the saturated hydrocarbons, the alkenes that we looked at, all the bonds in between carbon atom, they are always what? Single bond. But what defines a hydrocarbon being unsaturated is the presence of a bond that is not single. It's either a double bond or a triple bond. But for today, we are looking at the alkenes, and the alkenes mainly have what? Double bonds. And so the first member of the alkene is ethene, C2H4. And for the IUPAC name, the IUPAC name for the first member is ethene. The second member, when N is equal to 3, you're going to have 3 here. I want to put the formula of the compound. It's going to be C3H6. And here we are having the IUPAC name for this compound is propene. The next member, when N is equal to 4, we're going to have C4. When N is equal to 4, and so your formula becomes C4H8. So you have C4H8 as the formula for the next member, and you have your the IUPAC name for this compound is butene. Now, if you take a look carefully, you'll find out that each of the members of this alkene family, they differ from each group by a CH2 group. Now, this is C2H4. If you look at C2H4, C3H6 is just a difference of what? CH2. And that takes us to what we refer to as what? The homologous series. The homologous series, which is a group of a family of organic compounds that have same physical and chemical properties, and they differ from each other by a group of CH2. A group of organic compounds that have similar physical and chemical properties, and they differ from each other by a group of CH2. And so if you look at C2H4, the first member, ethene, it differs from the next member by a CH2 group. If you just add CH2C here, it gives you C3. If you add 2 here, it gives you H6. And so one major characteristic of the homologous series is that every member of the family differs from each other by a CH2 group. Now we can take the next member of the alkene family by simply adding CH2. That would be shorter for you than going through the formula. Just simply add your CH2 and you get the next member of what? The alkene family. And so if you put your C5H10, you've gotten your next member. And what is going to be the structural formula? The IUPAC name is pentene. Now, before we go further, let's add a little thing to it. Now, we have butene here, C4H8. And the name of this compound is butene. Another name for butene is but1ene. We can also call this butene as what? but1ene. but1ene. Now, structurally, they are different. No, sorry, they are the same. But this same butene you can also have a compound with the same molecular formula, C4H8. The same molecular formula, but the structural formula is going to be different. The structural formula is going to be different. You're going to have, let's put this one here. And change this name to but1in. Now the structural formula is going to be different. Okay, so the structural formula is going to be different. Now we're going to have the structural formula CH2, CH2, CH3. Now if you look at it carefully, the number of carbon atoms here and here, they are the same in these two compounds. Here you have 1, 2, 3, 4. Here you have, the hydrogen is 2, 3, 5, 8. Now let's look at this. Here we have CH3. Now let's look at this. We have 1, 2, 3, 4. We have 3 hydrogen. This hydrogen making it 4, 5, 8. So both of them are C4H8, C4H8. But their structural formulas are different. Now here you have the double bond, your saturation, after the first carbon atom. But here you are having it after the second carbon atom. Now that makes them structurally different. Now we call this kind of process isomerism. When compounds have the same molecular formula but different structural formula. Now the name of this compound is going to be different from the name we have here, which is but1in or butene that we said initially. The name here is but. This on saturation, the double bond is after the second carbon atom, and it's but2in. And so organic compounds exhibit isomerism. You could have two different compounds. They have two different structures, but their molecular formulas are the same. And so, likewise, pentene also exhibits its own isomerism. It has its own isomers. Now, when we have two compounds that have different structural formula and same molecular formula, we call them isomers. And we call that process, we call that phenomenon isomerism. Now, we're going to stop there. We can go on and name the compounds. But take note that the first 4 members of the alkenes, having from carbon 2 to carbon 4, or the first 5 members from carbon 2 to carbon 5, they exist as gases. From these downwards, we have the liquids and we also have the solids. Now quickly let's look at the laboratory preparation of ethene. Among the alkene family, ethene is one of the most important members of the alkene family. The word is not so strange to us. If the normal nylon bag we always use, the general name of quality is polyethylene bag. Now that word polyethylene came from the word ethene, polyethylene. So ethene is a member, is the most important member of the alkene family. The next thing we're going to look at is the laboratory preparation of ethene. Ethene, like I said earlier on, is the most important member of the alkene family. Now, how is ethene prepared in the laboratory? 2 compounds are used. Your ethanol and concentrated tetrasulfate 6 acid. Now, in carrying out this experiment, the volume ratio in which you react ethanol and the acid is ratio 2 to 1. That is, if you have 10 cm cube of the acid, you're going to react it with 5 cm cube of ethanol. In other words, your acid is in excess. Now, in the first stage of the reaction, you simply add, in the ratio 2 to 1, the acid and the ethanol into your round bottom, your flat bottom flask. And after doing that, you stir very well. After stirring, you set up the apparatus as shown in this diagram. Now, you heat, you apply the heat using your Bunsen burner. The mixture is heated to a temperature of 170 degrees Celsius. And after that, the ethene gas will be given off. Now the gas will go through these delivery tubes into an empty container. Now we'll come back to explain the function of this empty container. And from the empty container, the gas will also pass through these delivery tubes into a conical flask containing concentrated caustic soda, sodium hydroxide. Now, the function of this sodium hydroxide is to remove impurities. There are some gaseous impurities formed during the process of this reaction as a result of the concentrated nature of the acid. And those impurities are carbon dioxide and sulfur dioxide. Take note of that, it's a past question in wine. Those two impurities are removed, they are absorbed by the caustic soda. And the gas is now giving off, goes through this delivery tube and collected over water in this water trough and inverted gas jar. Now, ethene gas is slightly soluble in water, so it can be collected over water, and the gas accumulates right there in the inverted gas jar. Now, like I said initially, the reaction is in two stages. In the first stage, you react the acid and the ethanol. Now, in that first stage, what's going to happen? Now, this is the ethanol combining with the acid. It's going to form a compound we call ethyl hydrogen tetraoxosulfate 6 alongside the one molecule of water. And on heating, on placing it on the heating stand, the compound will decompose, giving you ethene gas, the gas we're interested in, and tetraoxosulfate 6 acid. You can see that the acid is regenerated. This acid can be taken back and reused again for continuous production of the ethene gas. Now, having looked at the laboratory preparation of ethene, let's quickly look at the physical properties of ethene. The physical properties of ethene. Most times, the physical properties of gases often poses a problem to students because there are so many gases you need to know their properties. But a very simple way to bring out properties of gas is to know the following. The properties of gas always borders on the following parameters. If you can just remember these parameters, it will be easy for you to bring out properties of gases. So quickly, let's look at ethene. With respect to color, ethene is a colorless gas. Now, when we talk about density, the density of gases is often done in comparison to air, to the density of air. Is the gas less dense than air, or is denser than air? One beautiful thing about the hydrocarbons, the first members of the alkanes, the alkene and the alkyne series, is that all those gases, they are all less dense than air. And so you simply write slightly less dense than air. First, now take note that not all gases may display all the parameters. Some of them you may only get just 3 or 4 of it. Some of them you can have all of it. Ethene has a sweetish taste when perceived. For its solubility is majorly the solubility of that gas in water. And so for ethene is slightly soluble or sparingly soluble in water. It is sparingly what? Soluble. In water. And for its action on litmus, ethene has no action on litmus. Now we looked at the physical properties, let's quickly look at the chemical properties. The first chemical property we're going to look at is the combustion of ethene. We're talking about combustion, we're talking about burning of a substance in air in the presence of oxygen. The combustion of ethene undergoes combustion to give carbon dioxide and water. And the interesting thing is that all hydrocarbons undergo combustion to give these two compounds. The alkanes and the alkenes and the alkynes, giving CO2 and water. So all you need to do is just to get your equation balanced. And so in balancing our equation, we have 2 carbon here. And here we have 1 carbon. So let's balance up our carbon. For the hydrogen, we have 4 hydrogen here. And here we have 2. If we have 2, we make it up to 4. For the oxygen, we have 2 atoms of oxygen in 1 molecule of oxygen. And so when we count the atoms of oxygen here, we have 2 atoms of oxygen here, plus multiplied by these 2, that's 4. And we have 2 atoms of oxygen here. So the total number of oxygen atoms on the product side of the equation is 6. And here on the reactant side, we have 2. So what do we simply do? We balance it up to what? 6. And what can we multiply with 2 to give us 6? And that's 3. And so that is the combustion reaction of ethene. It will undergo combustion to give you carbon dioxide and water. The next one we are looking at quickly is addition reaction of ethene. Please don't forget. Now, addition reaction is a reaction that all hydrocarbons that are unsaturated undergo. And whenever they undergo this reaction, they move from unsaturation to saturation. And now they move from being unsaturated compounds to become saturated compounds. Now, addition reaction involves 2 compounds. An unsaturated compound and an attacking reagent. And so simply put, if we want to explain what addition reaction is, we simply say that addition reaction is the combination of an attacking reagent across the double bond of an unsaturated compound to give you a product that is saturated, or a product that is level of saturation or degree of saturation is higher. And so if you want to look at the addition reaction of ethene, let's take the first example. Ethene undergoes addition reaction with hydrogen gas. And what's going to happen? It will give you a product that is saturated. C2H6, which is ethane. Now this is ethene. Now you can see that the double bond has been removed by the attacking of this attacking reagent, by the action of its attacking reagents. Removing the double bonds to now give you a hydrocarbon that simply has what? Single bonds, converting from unsaturation to saturation. And this compound is called ethane. Compounds. The halogens with chlorine, with bromine. Now let's bring out the structure of this compound to appreciate it better, to understand it better. You're going to have a compound that is saturated, no longer unsaturated. And what do we call this compound? We call this compound dichloroethane. If you remember the alkanes are ethane is C2H6. And so you now have an ethane compound that 2 of the hydrogen has been substituted, replaced with chlorine atoms. And so you can also have this for bromine. And this compound is called dibromoethane. Now we can move from Now we've looked at the combustion reaction under the chemical properties. We've looked at the addition reaction, and we're going to take a look at the next chemical property. Reaction of ethene with tetraodosulfate 6 acid. Now this reaction is a very interesting one because it leads to the production of a very important product. Now let's see how it goes. So we are looking at the third chemical property of ethene gas, ethene as a gas. Now ethene reacts with tetraodosulfate 6 acid, and this reaction is a very interesting reaction. The compound that will be formed first is an ester we call ethyl hydrogen tetraodosulfate 6. Now interestingly, we've seen this compound before in the preparation of ethene when we reacted ethanol with H2SO4. This compound was formed, and at the end of the day we add ethene as a product. Now ethene itself now is reacting with H2SO4 and is still forming this same intermediate compound, ethyl hydrogen tetraodosulfate 6. Now this compound will be further boiled with water to give ethanol plus tetraodosulfate 6 acid, H2SO4. So you can see that there is a similarity between this reaction and the reaction involving the preparation of ethene from ethanol. When you react ethanol and H2SO4, you're going to get ethene, and you're going to have this compound as an intermediate compound in that reaction. In this same reaction, when you react ethene and H2SO4, you're also going to get that same intermediate compound. And when this compound is further reacted with water, you're going to get ethanol and H2SO4. Now this reaction is what is used in the production of ethanol from hydrocarbon, ethene. America is a very good company that produces their ethanol not just from maize, but also from hydrocarbon, ethene. Now please take note before we go to the next chemical property. I can see that I wrote my chlorine as C, capital letter C and capital letter L. Your chlorine symbol is capital letter C and small letter L. Take note of that. Now let's look at the second chemical property. The fourth chemical property. Ethene reacts with air, with oxygen in air, without undergoing heating, to form a compound that is a very important solvent. So you have C2H4 plus oxygen, giving you CH2O, CH2. Now it's important we bring out the structure to see how this reaction takes place. Now let's not mistake the reaction involving ethene burning in air and ethene just reacting with air. The products are different. But before we continue, let's balance our equation. We can see that we have 2 atoms of oxygen here, but just 1 atom here. So in balancing it up, it simply means you're going to have half mole of oxygen molecule reacting. Now, in the reaction of ethene with oxygen without being burnt, the compound formed is epoxyethane. But when ethene undergoes combustion, burnt in air in the presence of oxygen, the compound formed is carbon dioxide and water. So we must take note that in this case it's just reacting with air without undergoing burning. But in the initial when we looked at the first chemical property, take note that ethene reacts with oxygen, undergoes combustion, burns in the presence of oxygen, giving you carbon dioxide and water. Now we're going to look at the last chemical property quickly. Last chemical property for ethene. Ethene undergoes oxidation. It's a very strong oxidizing agent. Ethene undergoes reaction and ethene is oxidized in the process. And so we have our ethene undergoing oxidation. The oxygen is going to come from potassium tetrahydromanganate 7, KMNO4. In the presence of water, and what will be the compound formed? The compound formed is called ethane 1,2-diol. So let's take note of that when ethene undergoes oxidation, it's going to form a compound called ethane 1,2-diol. And one last thing that also happens in this reaction is that this compound, potassium tetrahydromanganate 7, is purple in color. After this reaction, it will be decolorized. From purple, it will give you what? A colorless salt. To give you what? A colorless salt. Now there's one more chemical property that we are going to look at quickly for ethene. Very quickly. With bromine water. Now bromine water contains a compound, a weak acid we call oxobromate 1 acid. And so if you have your ethene, CH2, reacting with oxobromate 1 acid in bromine water, HOBRO, very unstable acid, you're going to have, and what do we call this compound? We call this compound 2-bromoethanol. 2-bromoethanol. Now this bromine water, let's take note that this bromine water has an orange color. It is orange in color. But at the end of this reaction, the bromine water will be decolorized. It becomes colorless. So take note that ethene decolorizes bromine water. And this characteristic of decolorizing bromine water is not just particular to ethene, it's for the unsaturated compounds. The unsaturated compounds decolorize bromine water. And after looking at this, let's quickly run through the uses of ethene. Quickly, which is the light ethene. The saturated hydrocarbons, like I said, that only unsaturated hydrocarbons can decolorize the bromine water. The saturated hydrocarbons cannot decolorize bromine water. And so this is a distinguishing test between the unsaturated hydrocarbons and the saturated hydrocarbons. So if you want to distinguish between the alkanes which are saturated and the unsaturated hydrocarbons, where you have the family of the alkenes and the alkynes, the distinguishing test between the two of them is that the unsaturated hydrocarbons can decolorize bromine water, but the saturated ones cannot decolorize it. When the alkane members react with bromine, the bromine retains its color. But for the unsaturated compounds, when they react with bromine, they decolorize it at the end of the reaction. Now let's look at the uses of ethene. So very important chemicals. Your ethanol, which is a solvent used in the production of so many chemical-based products. Your drugs, your perfumes, paints, varnishes, name it. Ethanol is always used as a major solvent in the production. The marker we are using, the solvent for producing the ink for this marker is ethanol. Ethanol is used for production of disinfectants, sanitizers. So it's a chemical of a very wide industrial use. Ethanoic acid also is used as a solvent in production of chemicals. Ethane-1,2-diol is used as an antifreeze in areas where you have very low temperatures and there's a tendency for the fuel inside the car to get frozen. Ethane-1,2-diol is applied in order to serve as what we call an antifreeze. And we also have epoxy-ethane, which is a very good solvent. Secondly, for the use of ethanol, for the use of ethane, sorry, important use of ethane is in the production of plastics. A very common and widely used plastic is the polythene bag, which rightly called polyethylene. It is produced using ethene as a raw material. Another important plastic is the polychloroethylene. Now take note that another name for polychloroethylene is polyvinyl chloride. And the abbreviation for this is PVC. And so ethene is a raw material for the production of PVC, polyvinyl chloride, or we call it polychloroethylene. Now PVC is well known, used in the production of PVC ceilings, production of PVC pipes used in plumbing. So ethene is a raw material widely used in the plastic industry. Thirdly, ethene is used in the production of a very important compound we call 1,2-dibromoethane. Now 1,2-dibromoethane is used as a petrol additive. What it simply does is it improves the quality of the petrol. And lastly, ethene in low concentrations is used to hasten the ripening of fruits. In very mechanized agriculture, in order for the fruits to be recovered without undergoing spoilage or destruction, the fruits are harvested while they are still strong and stored in storage tanks connected with ethene gas. And a low concentration of the gas helps to hasten the ripening of the fruit, so the fruit remains ripe and intact. And so with this, we've come to the end of our topic for today, alkenes, a family of the hydrocarbons. And so what we looked at today, to quickly summarize it, we looked at alkenes as an example of an unsaturated hydrocarbon. And it has the general molecular formula CnH2n. We looked at the members of the alkenes, that ethene is the first member. We have propene, we have butene, we have pentene, we have hexene. We also looked at the laboratory preparation of ethene being a very important member of the family of the ethenes. And we saw that ethene is prepared by the reaction of ethanol and concentrated tetraoxosulfate 6 acid. And we also saw the chemical and the physical properties of ethene. We saw the physical properties that ethene is a colorless gas. It has a sweetish taste, it's slightly soluble in water, it's less dense than air, and it has no action on litmus. We looked at the chemical properties of ethene today, and we were able to see that ethene undergoes combustion. It burns in the presence of oxygen, and it forms carbon dioxide and water. Like I told you earlier on, all hydrocarbons undergo combustion, giving you carbon dioxide and water. We looked at also the property of its reaction with tetraoxosulfate 6 acid, that ethene interestingly reacts with acid, H2SO4, giving you ethanol. And we also looked at its reaction with hydrogen, chlorine, bromine, a reaction we refer to as addition reactions. And that ethene, when you undergo these addition reactions, they are converted from unsaturated compounds to saturated compounds. And we also saw one of the chemical properties that ethene also undergoes a reaction with a very strong oxidizing agent, the potassium tetraoxomalate 7, giving you a compound called ethane-1,2-diol, which is used as an antifreeze in cars where they have very low temperature to prevent their fuel from getting frozen. And lastly, we are able to look at the uses of ethane, which is still outlined, that ethane is used in the production of important organic compounds, such as your ethanol, ethanoic acid, 18,1,2-diol. Ethene is used as a raw material in the production of plastics. The PVC, ethene is a raw material. Ethene is used in the production of 1,2-dibromoethane, which is used as a petrol additive. And ethene also in low concentrations is applied in agriculture. Now we're quickly going to look at some likely exam questions and see how what we have learned today could be applied in answering these questions. Screen and apply what we have learned today in these questions. Question number 1A, write an equation for the laboratory preparation of ethene. Question 1A, write an equation for the laboratory preparation of ethene. Roman figure 2, still under question 1A. What is the function of sodium hydroxide in the laboratory preparation of ethene? I take that again. What is the function of sodium hydroxide in the laboratory preparation of ethene? Question B, Roman figure 1. Give one isomer of but1ene. Give one isomer of but1ene. Question C. Give one use of ethene in 1. Agriculture, 2. The plastic industry. So this is all that we are going to look at today in the topic we have considered alkanes under the hydrocarbons. And so till we come your way again next time on this television teaching series program, stay safe and remain blessed. Thank you.